Hi, I Aniket Kanade welcome you to CKAD Masterclass for learning Kubernetes. Currently we are going through the chapter all about pods in which we are going to learn everything about Kubernetes pods. And this session is going to be about creating and troubleshooting simple pods. So let's begin. So first let's try to understand what is pod. Pod is the most basic building block of Kubernetes. If you see here, it's a picture of an ordinary pea pod. As you can see, a pea pod encloses several peas in it. But from tree's point of view, pea pod is a unit. A pod grows on a tree and it can be taken out of the tree and dissected into peas. But for a tree, unit is pod. Similarly, in case of Kubernetes, the basic building block is Kubernetes pod. A Kubernetes pod itself can contain several different containers. As you can see in this picture, a Kubernetes pod consists of one init container, and we will come to that later what init container is, then one main application container and one stats collector container. There is one noteworthy difference between a P pod and Kubernetes pod, other than of course one being a software component and other one being an edible thing. The difference is all the P's in the P pod are more or less same, they look same, they serve the same purpose, and that is exactly not the case with Kubernetes pod. The containers inside one Kubernetes pod are different, they serve completely different purpose, and they meant to have a completely different reason to exist there. So it's kind of a misnomer in Kubernetes to call it a pod. I see it more like a molecule in chemistry where multiple different atoms come together to form a molecule. Molecule is a unit. It cannot be further dissected into atoms, but each atom is different. Similarly, each container is different. It's not the replica of the same container. So that's a common confusion people make in their early stages of Kubernetes learning, that they think containers inside pods are replicas of the same container. That's not the case. In fact, that is the reason there are several applications that use a single container pod, because sometimes you don't need a complexity of having multiple containers. So for those applications and for those pods, container and pod are synonyms and they can be used interchangeably. But it's important to note that a pod can be a single container or it can be a multi-container, and each container serves a different purpose. Look at some of the properties of a pod. Containers in the same pod are scheduled together on the same worker node. What that means is, if a pod is a multi-container pod, all the containers must reside in the same worker VM. Containers in the pod can share resources such as file system. This is because since all the containers are scheduled on the same worker VM, they can share the resources. And all Kubernetes administration commands such as kubectl apply and kubectl create operate against pod, not against individual containers. What that means is, since Kubernetes treats pod as a unit, you cannot have a CLI commands that work on individual containers, but a command must act on an entire pod. So we are going to do a quick demo of running a simple single container pod. The link to this GitHub page where all the commands are listed is provided in the description of this video. And as a prerequisite, you need to have munikube installed. Instructions for the same can be found here along with the YouTube video that describes the same. Very first thing we are going to do is verify that munikube is running and Kubernetes is in healthy state. So let's just check the status of the system. We can see that munikube is running, one node is in ready state, and all the Kubernetes pods are running as well. Then we are going to execute the command to run a pod from busybox image. You can see that the command to start a pod is kubectl run. Then we provide the name of the pod, then the image from which the pod is to be started. Since this is a single container pod, there is just one image. And dry run equal to client. This switch tells Kubernetes that I don't want to actually create the pod. I just want to simulate the creation and see how the command goes. And then -- command sleep 3600. This is the container entry point that you would otherwise provide in Docker. So the response says pod test busybox created, dry run. So actually the pod is not created, which we can verify. There is no pods in default namespace. Since we haven't provided any namespace here, all the commands are executed against default namespace. And similarly here also, since we haven't provided any namespace, the get pods command also got executed for the default namespace. A quick note on a namespace. In Kubernetes, namespace is a way to collect all related objects together. So one application generally has one namespace, and all the pod services deployments for their applications reside in that namespace. Let's move on with our topic. Now we are going to actually create the pod without using dry run. kubectl run test busybox image busybox. Now this says pod test busybox created. And if we do kubectl get pods, we see that one pod is running. 1 out of 1 means this pod has one container, and that one container is in ready state. Status says running, and the age of this pod is 9 seconds. So that's the get pods command. We can also use -n default to specify the namespace that we want to use, and we will get the same output. Now let's inspect the pod created. To know the details of the pod, command is kubectl describe. kubectl describe lists all the information about the pod. What is the name of the pod, what is the namespace of the pod, etc. Then the IPs, this is the Kubernetes IP created on the CNI network. Then what are the containers inside the pod? Since we have just one, it is named test busybox, and different conditions, and the last log lines created by the container are here under the heading events. We will go through the details of describe later. This is enough for now. There is also a way to get the entire pod information in a YAML file with this command. Get pods pod name -o YAML. So that tells Kubernetes to create the output in YAML format, and we can redirect it to a file. So if we look at the file created, this has the Kubernetes specification or the pod specifications in the YAML format. We're going to do a separate session altogether for understanding the YAML format of Kubernetes objects. But right now it's enough to know that all the information we provided on the command line is present in this YAML file. Okay, so that's it about creating simple pod. In the next video, we are going to look at imperative declarative commands and different ways of doing the same thing. Let's spend some time understanding imperative versus declarative commands. In case of imperative commands, you instruct Kubernetes what to do. And in case of declarative commands, you just provide the final state that you want to achieve and let Kubernetes choose what to do. Let's try to understand this concept by taking an example of fetch the ball game that you play with the dog. You throw the ball and tell the dog to go get the ball. Dog runs and gets the ball for you. Next time you just act like throwing the ball, but the ball is not actually thrown, it's still with you, and you tell the dog to go get the ball. The dog goes and gets nothing because there is no ball. Now let's play the same game but with a different command. Now the command that we are going to use is I want the ball here. So once first time you throw the ball and tell the dog I want the ball here. Dog now knows the ball has been thrown. The dog goes and fetches the ball and gives it to you. The next time you just act like throwing the ball and say I want the ball here. Now the dog knows the ball is already here, so dog doesn't run and the ball is there. First case is the declarative command, so regardless of what the action is, it's go get the ball, so dog is going to go and try to get the ball. In the second case though, you are telling the dog that I want the ball here, so if the ball is already there, the dog is not going to go and fetch the ball. Declarative command and imperative commands is a philosophical difference between asking system to do something and asking system to get a result no matter how the system wants to do it. kubectl create, kubectl delete are the examples of declarative commands. Whether the pod exists or not, kubectl create is going to try and create it. Similarly, kubectl delete is going to try and delete whether the pod exists or not. As against, kubectl apply is the example of declarative command. In case of kubectl apply, Kubernetes looks at the current state of the object and the desired state provided by the apply command, and then either updates the definition, creates the pod if it doesn't exist, or does nothing. So that's imperative and declarative commands. In the next video, we are going to see how we're going to execute declarative commands against simple pod. Let's now look at working with pods using declarative commands. In the previous demo session, we created this tmp busybox.yaml file using kubectl get command. We are going to use this YAML file which defines test busybox pod to create another pod with the name test busybox declarative. So for that we have to edit the file first. That's the pod definition template. We're just going to edit the name because we want the image and everything else to be same. And don't worry about rest of the things in this file. The name is edited. Save it. And then we use a declarative command kubectl apply. Kubectl apply will look at the file and definition inside the file and create the pod if it doesn't exist, or modify the pod if it already exists. Kubectl, it says test busybox declarative created. So if we execute get pods, now we have a second pod test busybox declarative created from this file. Next, what we are going to do is we are going to use a YAML file to update the image definition of the pod. Now we need to regenerate the YAML file using get pods command because the previous YAML file is now invalid since we changed the name and the object underlying object has got changed. So we regenerate the file get pods. This time we pick kubectl declarative as the pod to work against and regenerate the YAML file. The next thing we are going to do is edit busybox.yaml in editor and set the name image as nginx latest. Oops. Temp busybox YAML, and we need to look for This is where the image is defined. It says busybox latest. We are going to change it to nginx latest, and we do apply. If you look at this, it's the same command that we executed previously, but this time we expect Kubernetes just to change the image reference because the pod already exists. And the response this time says declarative configured. And if you look at the get pods, if we look at the describe pods, see container image is now nginx latest. So that's it about, oh yeah, I forgot one more point, that the dry run command that we learned earlier, it can be used to generate a pod definition template to be used in declarative commands. The format of the command to use to generate a boilerplate from dry run equal to client switch is this. You say run test busybox image command. I think there is some mistake in this command. What we need to do is we need to do kubectl run test busybox image latest. Yeah, up to this it's fine. Then we need to do dry run OYAML, because command switch needs to be the last one. It goes to the container sleep 60 and then redirect it to the file. So using this command, kubectl run pod name, image name, and dry run client OYAML, this will generate a YAML formatted output for a pod definition, and we are redirecting it to a file called testpod.yaml. So now if we look at the file, that's the pod definition template, which can be modified and used in declarative commands to create different pods from this template. So that's it about declarative commands and a demo of declarative commands. Let's summarize what we learned in this topic. We learned that pod is a basic building block of Kubernetes. We learned that each pod serves one purpose. For one microservice, there is one pod. We also learned creating and working with simple single container pods. And we learned imperative and declarative commands and a dry run trick to generate YAML template or boilerplate. So that's it about simple single container pods. Hope you found this useful. Thank you.